Hi, good evening everyone. Welcome to Unacademy YouTube channel. Are you able to hear everyone? Are you able to hear everyone? Okay, welcome to Unacademy Plus YouTube channel. Okay, welcome to Unacademy Plus. Right. I wish you a very happy and prosperous New Year to you all and your family members. Very happy New Year. Welcome to 2021. So I hope in this 2021 you will be get succeed. All the best for every student. Okay. So from today onwards we are going to discuss an electrostatics topic, capacitors. Combination of capacitors topic. Okay. So is everyone there online? So this is about our courses features. Okay. So you can join in Unacademy Plus course by using code Kiran P Live. Capitals. Or you can use Kiran MSc 08-5140. Use this code also to join. Okay, you will get the discount. So you will be entering into the class also, free special classes. Our free special classes daily from 4 to 5 p.m. on second year topic and 6 to 7 p.m. on first year topic. So don't miss everyone. You can join and watch these classes. So very useful to you, not only for EAMCET, all for IIT, NEET, JEE, for every entrance exam. So these classes are useful. So we'll start combination of capacitors. First of all, how can we get the capacitance? What is meant by capacity? What is meant by capacitor? So capacitor means the device which can store the charges. Okay. Capacitor means what? The device which stores. So the device which can stores the charges. Like for example, see water tank. It stores the water. So like that capacitor, what? It can store the charges. For example, see generally fans are having capacitors. They are nothing but called condensers also in the name. Okay. So they can store the charges. Generally, if capacitor is slow down now, so the fans can move very slowly. We can change the capacitance condenser because charges will be decreases. So the capacitor is having what more charges, so that it can supply more charge. So electrical energy supplies, a fan can move fastly. So capacitor is what? It is a device to store the charges. It can store the charges. Okay. Capacitance. The capacity of a capacitor to store the charge is called capacitance. Capacitance. The capacity of a charge. What is that? The capacity of a capacitor to store the charge is called what? Capacitance. It's capacitance. Generally, see, charge is directly proportional to the potential. We know that V equal what? 1 by 4 pi epsilon naught Q by R now. So V proportional to Q or Q proportional to V. That proportionality constant we can say C, capacitance. So C equal to Q by V. What is the unit? Coulomb per volt. It is called farad. Okay. C Q equal CV or C equal Q by V or V equal to Q by C. Okay, no? Now, generally see, depends on the different shapes of water tank. different different shapes and sizes of water tank, different volume of the water can be stored. So if shape is more water, less means less, like that. See, depends on the different shape of the capacitor also. Storage of number of charges will be changes. So it is like water system. So it depends on mainly size and shape. See, these capacitors are generally different types: parallel plate capacitor, spherical capacitor, cylindrical capacitor, paper plate capacitor, like different. So mainly we can use parallel plate capacitor. So parallel plate capacitor means what? It consists of two plates. Means two conducting plates arranged near to each other. Having one is charged, one is having what? Positive charge, and another is having negative. Okay. So means in between it is positive, it is negative. So total charge means what? 0, but generally charge on capacitor means charge on the first plate we can take. Okay. So how can we increase the capacitance of a capacitor? By lowering the potential, we can increase the capacitance, because inversely. For example, in take a positive conductor plate having positively charged. Now take an uncharged conductor placed near to it. What will happen due to induction? Equal and opposite charge will be induced on other side, equal charge. Now see, connect this plate to earth. What happens? The charge can move towards the earth and electrons can move towards the plate. So after that, what will happen? Their positive negative gets neutral. So finally only negative charge will be remains. See, that means the potential is here what? Decreased. Negative means lower. So potential decreased means what? Capacitance is increased. Like that, the principle of capacitor is what? By taking when an uncharged conductor is placed near to a charged conductor, then charge opposite, equal and opposite charge can be induced to the uncharged conductor, and then it should be connected with the ground. Then its potential can be lowered so that its capacity can be increased. That is the principle of capacitor. Okay. So generally in a combination, now in combination of capacitors we can use this parallel plate capacitor only, mainly combination. And see guys, everyone, see in this YouTube sessions we are taking half an hour classes. So for complete classes you can go through our website and come to our special classes and plus classes. You will get the complete classes, complete topics. Okay, so follows. Due to that you can crack the EAMCET and all exams also, all entrances. So first, combination of capacitors. First, series combination. Series combination. So in series combination, see, so what is series combination? End to end. Series combination. See, when two or more capacitors are what? Connected end to end. From end to end connection. See, positive, negative, positive, negative. Second plate of first capacitor to first plate of the second capacitor. And second plate of second capacitor to first plate of the third capacitor, like that. So, and finally what? First plate of the first capacitor and second plate of the last capacitor are connected to terminals of a battery. Terminals of battery. So generally in series what here? charge remains constant. So Q or Q1 or Q2 is constant, but the potential will be what? Different. V equal to V1 plus V2. Actually, we have see Q equal to CV, C equal to Q by V, or V equal to what? Q by C. Okay. So total V equal to total charge by C in series. V1 Q1 by C1, Q is constant na? So V2 Q2 by C2, that is Q by C2. Therefore substitute in first equation V, that is Q by CS equal V1 Q by C1 plus V2 Q by C2. So that 1 by CS equal to 1 by C1 plus 1 by C2, or in series C1 C2 by C1 plus C2. Means in series combination of capacitors, it reverts to resistance. The equivalent reciprocal of the capacitance is equal to sum of the reciprocals of the individual capacitances. If you connect n number of capacitors, then it is equal to what? 1 by C1 plus 1 by C2 plus 1 by C3 plus so on 1 by Cn. Suppose if you take n identical, n number of identical, so 1 by C plus 1 by C plus 1 by C, that is equal to n by C, that is C is equal to what? C by n. Now, what is the ratio of charges here? Q1, Q2 or Q3, so on. It is equal to 1:1:1 ratio, right? But what about the potential ratios here? V1, V2, V3, so on. Q by C1, Q by C2, Q by C3, Q cancel. So 1 by C1 is 2, 1 by C2 is 2, 1 by C3 is 2, so on. Right? How to find individual potential? See, Q equal to, we have Q1 equal to Q2. No? Q is what? CV, C in series into V total. C1 V1, Q1, Q2, C2 V2. Equate these two. That is Q equal to Q1 you can take. So that therefore V1 equal to say CS by C1 into V, right? And equate these two, that is Q equal to Q2, CSV equal to C2 V2. So V2 equal to CS by C2 into V, like V3, V4, like that for nth potential of nth capacitor, CS by Cn into V. Is anyone there watching here? Once this message here. Okay, now this is about nth potential. And next coming to parallel combination. You see in parallel combination. capacitors in parallel. So parallel means what? First plates of all capacitors to first terminal of battery, and second plates of the all capacitors to second terminal of the battery. They can connect like this. So okay, all the first plates of all the capacitors are connected to first end of battery, and second plates of all capacitors to connected to second end of the battery. Potential difference, then that is said to be parallel combination. Parallel combination, see, total charge can be divided. See, it is splitting Q1, Q2. But see, terminals are same. It is 1, it is 2 now. So only positive and only negative. So that potential is here common, here constant. That is V equal to V1 equal to V2, constant. But what about total charge? Q equal to Q1 plus Q2. So what is Q here? CV, that is in parallel na? Q1, C1, CP into V, C1 V1, Q2, C2 V2. Substitute here na? CP into V equal to C1 V1 plus C2 V2. But see, V1 V2 cancel, common na? So that what will we get here? Total C equal to C1 plus C2. So in the parallel combination, the resultant of the or equivalent capacitance is equal to sum of the capacitance of individual capacitors. Okay. So if n number of are connected, so in parallel, C1 plus C2 plus C3 plus so on, Cn. Okay, na? And next, what? In case of identical, C equal to C1 plus C2, C plus C plus C, that is N into C. This is the parallel combination. Okay, so this is about parallel. Now tell me, what is the ratio of a potential V1, V2, V3, so on. 1:1 ratio, right? What about charge ratio Q1, Q2, Q3, so on? C1, C1, V1, C2, V2, we cancel now. So C1 is 2, C2 is 2, C3 is 2, so on. And how can we find here? How can we find each charge? See, V equal to V1 equal to V2 na? So V is what? Q by C in parallel. V1 Q1 by C1, V2 Q2 by C2. Equate these two. Q1 equal to, see, C1 by Cp into Q. Equate these two. Equate these two. Q by Cp equal Q2 by C2 na? So Q2 will be what? C2 by Cp into Q. Like that for Q3. C3 by Cp into V. C4 by Cp into Q. Q4. Like Qn. Charge through nth capacitor. Cn by Cp into Q. Okay. Right? this is about parallel. And now see, finding the equivalent capacitance in series and parallel combination is very important. So how can we find means we will discuss in the next tomorrow class. So now we have continuously classes up to 6. We have daily class. Actually class is at afternoon 1 p.m. afternoon at 1 p.m. Okay, so 1 to 1:30 you can join. Then we'll continue this topic, combinations, and what is the capacitance of parallel plate capacitor. So next after that, what is the effect of dielectric? About all we can discuss. Okay now? So we'll meet in tomorrow class. Okay. So bye all of you. Bye bye.